In this video, we're going to look at the polar coordinate system, another method for plotting points in the plane. Recall in the rectangular coordinate system, a point is identified with an ordered pair x, y that identifies its location relative to the origin. For example, the point -3, -4 would be moved 3 units to the left and 4 units to the right of the origin. In the polar coordinate system, a point is identified with an ordered pair r theta, where r is the distance from the origin, and theta is an angle measured from the positive x-axis. Let's look at some examples. Each of these ordered pairs identifies a point in the polar coordinate system. Let's look at these. The first one, 5, 3 pi over 4. Now you can think about the radius first or the angle of rotation first. I like using the angle of rotation first. With a rotation of 3 pi over 4 from the positive x-axis, we'd be on this line over here. With a radius of 5, we'd be 5 units from the origin. 2, 3, 4, 5, it would be right here. 2, 7 pi over 6. Well, we'll first go our rotation of 7 pi over 6 down here in the third quadrant. A radius of 2 would put it right here. -6, 3 pi over 2. Well, first we do the rotation of 3 pi over 2, puts it down on the negative y-axis. If our radius were a positive 6, it'd be right here. But the negative radius is going to reflect this about the origin. It'll be up here. Note that this ordered pair is equivalent to an ordered pair written as 6 positive pi over 2. -3 pi over 3. We first go the rotation of pi over 3. If it were a positive 3 radius, it'd be located here. The -3 radius again reflects it about the origin and locates it right here. Note that this point, or this ordered pair, is equivalent to an ordered pair with a positive radius of 4 pi over 3. To -pi over 6. Well, now we'll rotate backwards into the fourth quadrant, pi over 6. With a positive 2 radius, we'd put it right here. -5, -2 pi over 3. So first rotate backwards 2 pi over 3. The negative radius will reflect about the origin and would locate our point right here. Note that this is equivalent to the ordered pair +5 pi over 3. After plotting several points, we have observed that in polar coordinates, a point can have multiple representations. Suppose that r theta and r prime theta prime are polar coordinates where r is not equal to 0 and the angles are measured in radians. Then r theta and r prime theta prime determine the same point P if and only if one of the following is true. The radiuses are the same sign and one of the angles is an even multiple of pi greater. Or if the radiuses are opposite in sign and one of the angles is an odd multiple of pi greater. For example, given the ordered pair 5 pi, that would identify the point in the polar coordinate system that's right here. If we were to add any multiple of 2 pi to that, we would get one more complete rotation and we'd get the point 5, 3 pi. Another complete rotation around would give us the ordered pair 5, 5 pi. Similarly, we could pick our radius to be negative and then maybe use an odd multiple of pi greater. Since our angle started off with pi, an odd multiple of pi greater would be 2 pi. So the ordered pair 2 pi would be right here. If it were a positive 5 radius, it'd locate this point, but the negative 5 radius does reflect it around the origin, and we do get the same point in the polar coordinate system. Let's try another one. Let's plot the point 6 pi over 6. Now 6 pi over 6 would be a rotation of pi over 6, a radius of 6, we'd put it right here. To find an equivalent representation of this, we could add 2 pi to this rotation, and we would get the ordered pair 6, 13 pi over 6. Another equivalent representation would be the ordered pair 6, 25 pi over 6. Another one would be 6, 37 pi over 6. I hope this is helpful, and I'll see you in the next video.